in this session we will discuss the remaining part of exercise 14.3 14.3 and here we have the fourth question. So let's go for 4.3. We will differentiate with respect to x. So we have to differentiate all these expressions with respect to x. So we will solve some of this in this session. So here we have this e power cos x. We assume it as a y is equal to e power cos x and take the log on both sides. So this is ln y and this is ln e power cos x, and this is becomes ln y is equal to cos x. This is ln and e are reciprocal to each other, so this will cancel out and will give 1, and this cos x will remain there. So now differentiate it with respect to x on the left hand side and right hand side. So for differentiating this, we will have this 1 over y and then dy by dx, and similarly here we have dy by dx of this cos x and we have minus sin x. So this y will appear here. So dy by dx is equal to minus y sin x. In place of y we will write this e power cos x. So here in place of y we will write e power cos x and this minus sin. So this is the differential or the gradient of or differentiation of this e power cos x is this. Now similarly also let's solve this y e power x sin x. Take log on both sides, and this is ln y and this is ln e power x and sin x. So we'll have this ln e power x and plus ln sin x, and ln cancel and then it becomes x, and this is, so by taking simplification we obtain this. And now differentiate. So by differentiating on this side, this is 1 over y and dy by dx, this y x is 1 and this is ln sin x, and then differentiate this sin x, we will get the cos x. So this cos x upon sin x is basically cotangent x, 1 plus cotangent x, and this y will multiply here, and dy by dx is this, and in place of y we will write e power sin x. In place of this cot x, 1 plus cot x, so we'll multiply sin x with this and sin x there. So this is cos upon sin, so this cancel will with this, and this becomes cos x. So e power x sin x plus cos x. So dy by dx will be e power x sin x cos x for this e power sin x. So this is very important. Similarly for x square e power cos x, taking ln on both sides, and then this becomes ln x square and this is ln e cos x, so this becomes cos x. So now differentiate, and we will differentiate it this way, and here with this 1x square and then x square, differentiate to get 2x, and this sin cos x equal to minus sin x, and then this x will cancel this one, so my 2 upon x and then minus sin x, and this multiply y here. So by in place of y we will place the value of y, which is this one. So in place of this y we have this value, and then simplification we have obtained this x cancel out this one x, and then x e power cos x and 2 minus x sin x. So we for this one, and for this one let's say this one's sin x e power 2x minus 1. So this way can be shifted here, and then we can write it like this, and this is simple. So this is very important. So then this e is a constant, and then this is u and v, and applying u and v formula and we have solved it. So this is first function derivative of second and derivative of first, and then this is solved. Finally we got this result. Similarly for this one, so this is uv. So u part is we take it as a u, whole u, and this is v, and this can be settled on like this. This is again uv. So similarly this is simple. This part is solved here, and the remain is this. E power x is same, so x minus x, so this is same, and this is e power 2x, and then simplification, this x common, e power x common, and then we can reduce it 1, and then in the upper part we have this. So this is simple. Now find the gradient of the tangent to this y is equal to 2x cos 3x at x is equal to pi by 3. So take the differential. So this is u and we solve it, and by simplification we have obtained this result, and place it at x is equal to pi by 3, and by substituting pi by 3 in place of x and simplification we obtain this, and finally the result is -2. Similar for this one, differentiate. This is u, this is v. We differentiate it, and we obtain some results like this, and placing in place of x pi by 4. So we place in place of x, we place pi by 4, and we obtain this result. Eventually we have this one, simplified form. In part 6, similar kind of problem, and this is question number 7. Dy by dx have to find, and we have given this e power y sine 3x, and taking log on both sides, so this becomes y and this becomes this. So this is simple. E power y 3 cos 2x, and take natural log on both sides, and this becomes this. And we take this, and this becomes this. And this is a challenging one. So it's a bit lengthy. So let's solve this question number 9. So we have let's first read the question number 9, and then we will come here. This is question number 9. A curve has the equation y is equal to a sin x plus b cos 2x. The curve has a gradient of 5 under root 3 at when x is equal to pi by 6, and has a gradient this when pi x is equal to pi by 4. Find the value of a and b. So at x is equal to pi by 6, the gradient value is 5 under root 3. At x is equal to pi by 4, the gradient value is 6 plus 2 under root 2. So we have to find, we have to differentiate it, dy by dx, and then substituting this x in place of x, we will get this. As a result, we have these two equations. With this second equation, with this we have one equation. So with this we have another equation, and by substitution we can find the result a and b. So this is problem. A sin x cos 2x, we differentiated a, this sin becomes cos x, and b is here. This cos x is basically minus sin 2x, and then 2x becomes this 2. So this is a cos x minus 2b sin 2x at x is equal to pi by 6. We'll place this pi by 6 here, and we get this result 5 under root 3. So for this pi by 4, we place this pi by 4, this becomes 1 under root 2. By placing pi by 2, this becomes 1. So a under root 2, and this becomes this. So pi by 6 is under root 3 by 2. So this is at pi by 6. So at pi by 6, so we will place here pi by 6, pi by 6. So this is pi by 6 means under root 3 by 2, and this pi by 6 means pi by 3. So this net will be pi by 3. So with this pi by 3, sin pi by 3 is under root 3 upon 2, cos pi by 6 is under root 3 upon 2. So this 2 will cancel with this one, and we have this under root 3 on this. We take common and simplify it, and eventually we will have this a minus 2b is equal to 10. So this is equation number 1. Similarly, for this equation, we will place pi by 4 here, pi by 4 here, and with this pi by 4 we will have this value, and we will eventually have this equation. And on further simplification, we have from equation 1 a is equal to 10 2b. So 10 2b in this equation, 10 2b can be placed in place of a. So this is in place of a 10 2b, and we simplify for b, and we have obtained b is equal to minus 3. And by placing this b is equal to minus 3 here, we can find the value of a, which is here 4. So this is very important problem, and in the next session